Hi, today we're going to cover factorials, combinations, and permutations. So first I'll talk about factorials, and the general notation for factorials is this: n factorial is equal to n times n minus 1 times n minus 2 until 1. So where n is a positive integer. So if that cries out to you, perfectly fine. That's good. If you understand that, you can move on. But if this is a little confusing to you, basically what it is n is just any number that we're familiar with: 1, 2, 3, 4, any number. And when it's excited, when it has an exclamation mark, it means that it's a factorial. So that means that the result of the factorial is whatever number times every number before that, all the way up until 1. So let me show you what I mean. 3 factorial would be 3 times 2 times 1, and we reached 1, so we stop. And all of this combined, the product of all these numbers would be 6. The same way, 6 factorial would be 6 times the number before that, 5 times 4 times 3 times 2, all the way up until 1. And we would get the product of all these numbers as the result of 6 factorial. It's very simple, and once you understand it, it's really something that you can't forget. And one of the most useful ways you can use factorials is in combinations and permutations, as well as proving questions. But in order to do so, you need to be able to manipulate the n factorial in a way that's helpful to you. And one of the easiest ways to do that is basically rewriting the general notation in such a way that will help you. So I'll show you what I mean. From the above equation, notation, we can tell that n factorial is n times n minus 1, n minus 2 times n minus 3 times n minus 4, and so on until we reach 1, right? And so if the question you're dealing with has to do with n minus 2, for example, or n minus 2 factorial, let's say, then it would be handy for you to rewrite n factorial in terms of n minus 2 factorial. So if we look at this equation, if we just cut the first part off and we look at the rest of the expression, then we can say that this entire expression is equal to n minus 2 factorial, because we take n minus 2 as the starting number. And if we do that, n minus 2 minus 1 would be n minus 3. N minus 3 minus 1 would be n minus 4. And so we see that it holds true, and we can rewrite this as n minus 2 factorial. And we'll rewrite whatever was in the front. And this sort of manipulation you can do with any number down the line. You can start at n minus 3, you can start at n minus 4, you can start at n minus 1, and you can even do n plus 1, depending on how you manipulate your equation. But this is a very handy way of manipulating factorials, or especially factorials of a variable, of an unknown integer. And it'll come in really handy in the future. But if you generally know what factorials are and what it is, you should be fine for more complex problems. Next, we get into combinations, and suddenly the expression gets all confusing with a lot of numbers, with a lot of letters, and all these exclamation marks. But basically, if you remember that combinations are the number of ways you can choose a certain amount of people from a total amount of people, if you remember that, combinations will be a little easier to understand. But purely from an algebraic standpoint, this is what combinations are. This is the identity. N combination R, or NCR, is equal to n factorial over n minus r factorial times r factorial. So if you take 6c3, for example, we can say that 6c3 is equal to 6 factorial over 6 minus 3 factorial times 3 factorial. And if we simplify that a little bit, it makes it 6 factorial over 3 factorial and over times 3 factorial. So from here, you can put everything in the calculator, or you can do the calculations manually, but there's a quick simplification that you can do that may help you out if you're calculating manually. So if we see 3 factorial in the denominator, we can rewrite the above factorial as 6 times 5 times 4 times 3 factorial, right? Because it'll be 3 times 2 times 1, and that's the same as 3 factorial. And that way you can make this fraction cancel the denominator and the numerator and get a simpler result to calculate if you're doing this manually. So that's a useful manipulation that you can use. If we look at 6c1 here, we can tell that 6 factorial over 6 minus 1 factorial times 1 factorial would be equal to 6 factorial over 5 factorial times 1 factorial is just 1, so we can just ignore that. And that means that if we rewrite 6 factorial as 6 times 5 factorial, we can cancel these, and therefore 6c1 would equal to 6. In the same way, if we do 6c6, we would get 6 factorial over 6 minus 6 factorial, times 6 factorial, and this would equal to 6 factorial minus over 0 factorial times 6 factorial. And from here, we can cancel the 6's, and this gives us 1. 0 factorial is 1, and I'll make a separate video on the proof of that. But here are some general things that you can remember from these two examples. Any number C1 is equal to that exact number, and any number C to that number where n and r are equal, it'll always equal to 1. So if you remember these two, sometimes it'll save you some handy it'll save you some time when you're calculating these combinations, so keep that in mind. Finally, we have permutations, and permutations are very similar to combinations, but in the real world context, if we apply it in the real world, it would basically mean picking a number of people from a total number of people and ordering them in a specific order. So you can remember it that way if that makes it easier, or you can remember it this algebraic way, which is npr is equal to n factorial over n minus r factorial. And if you realized, it's very similar to ncr, except there's no extra r factorial in the denominator. So it might be easy to get these two confused. Make sure you don't forget that npr doesn't include the r, and ncr includes the r factorial at the end. So similarly, we can apply these to actual numbers, and 5p3 in this case would mean 5 factorial over 5 minus 3 factorial, which would mean it would equal to 5 factorial over 2 factorial. And if we rewrite 5 factorial as 5 times 4 times 3 times 2 factorial, then we can cancel these, and therefore the answer would be 5 times 4 times 3, which is 20 times 3, and it's 60. 5p1 would be 5 factorial over 5 minus 1 factorial, which would mean it becomes 5 factorial over 4 factorial. And if you rewrite the numerator as 5 times 4 factorial, then we can cancel these, and the result will be 5. In the same way, 5 factorial over 5 minus 5 factorial would make it 5 factorial over 0 factorial, which is just equal to 1, which means the result will be 5 factorial. So these are the ways you can apply permutations, and in following videos, I'll explain how you can apply combinations and permutations in order to answer counting principle problems. But that's the basic understanding that you need for factorials, combinations, and permutations. Just remember that they all deal with positive integers, and you can't really use permutations and combinations without the knowledge of factorials. And these all three of these concepts go hand in hand together. So yeah, thanks for watching.